I am the Beng Tutor and welcome to our channel Beng and Natural Science Tutor, where we break down tough topics into easy steps. If you are new here, hit that subscribe button so that you don't miss out on future lessons. Let's dive in. For today, we are going to solve this limit. Consider the position vector RT equals to xti plus ytj plus ztk with Perimi equation xt equals to ln of t over t, yt equals to exponential to the power t root of t, and zt equals to t to the power t to the power negative 1. If this exists, we need to evaluate the limit as t approaches infinity for RT. Let's start solving. The first thing we need to do is solve. The first thing we need to do is to take the limit for all the parameters, which is x, y, and z. We take the limit individually and solve them individually. At the end, that's when we'll compile a single answer. So let's start with x. For x, xt is equal to ln of t divided by t. Let's take the limit for this bad boy. Say the limit as t approaches infinity for ln of t divided by t. If we try to plug in infinity there and infinity here, we'll find that ln of infinity is infinity, then it will be infinity over infinity, which will make the form to be indeterminate. So what we are going to do is we are going to use L'Hopital's rule. We are going to differentiate this bad boy, and we are going to differentiate this bad boy too. When you differentiate the top part, we are going to get 1 over t. When you differentiate the bottom part, we are going to get 1, which is just 1 over t. Now, remember, the limit was when t is approaching what? Infinity. So we're taking the same limit there. So the limit as t approaches what? Infinity. Now, if you look at what we have here, the limit as t approaching infinity for 1 over what? 1 over t. This is 0. That's 0. So for the first perimeter, xt, our answer is what? Is 0. Let's try to search for the perimeter of y. So yt is equal to e to the power negative t root of t. This guy also is the limit as t is approaching what? Infinity. So first, let's analyze. We need to be analyzing every question, every perimeter. Say when we plug infinity here for t and we plug in infinity here, exponential to the power negative infinity, it will give us 0. Root of infinity, root of a very, very big number, which with no bounds, which is ever increasing, it will give you the same. So if you plug in for infinity here, we're getting 0. We're plugging infinity here, we're still getting infinity. So it will be 0 multiplied by infinity, which is undeterminate. So we can try to look at this. If at all we drop this down, it becomes root of t over e to the power t. Even if we try to we try to use L'Hopital's rule for this, we're going to be getting almost the exact same thing, because it is still going to reduce. So we can try to see how and where L'Hopital's rule will take us. So let's say I write this boy the way he is. We see how it will turn out. Let's differentiate the top part and differentiate what? The bottom part. So when we differentiate the top part, what are we going to get? We're going to get this is the same as t half, isn't it? So when you differentiate that boy, we're going to get half t to the power negative half, isn't it? Then divided by for this, we are going just to still get the same thing. Now look at this boy. Look at now how that is. So we can try to bring this down as 1/2 e to the power t. Now see, that's a negative power. It can drop down and become positive. So it is going to be t half, isn't it? Now remember, this whole thing there, it was as a limit as t was approaching what? Was approaching infinity. Now if you plug in infinity where there is t here, e to the power t is infinity, but e to the power negative t is 0. But e to the power t as t is approaching infinity is what? Is infinity. But e to the power negative t as t approaches infinity, it's what? 0. So for this guy alone, we're going to get what? Infinity. And here t to the power half, and the t is what? This t is infinity. Infinity, root of infinity is still infinity. So what we are just going to get here is 1 over infinite. And for limits, 1 over infinite is what? Is 0. So for yt, the perimeter yt, we have proved that it's what? Is 0. And the perimeter for xt, we have proved that it's what? Is 0. What are we remaining with? We are remaining with the perimeter of zt. So we also consider it alone, so that we try to find out the answer for the perimeter. So zt is equals to t to the power negative 1. So we can try to rewrite this bad boy in this way. We can rewrite him in this way. We'll write t, then for that t, t to the power negative 1 is just t. It's just 1 over what? 1 over t. Now if you look at this when you look at this, if you plug in infinite for this and infinite for that, it will be infinite to the power 1 over infinite, which is just 0. That form is indeterminate. So let's just write it with a limit, the way we are doing for O. So for this boy, we need to put him into a form where we can use L'Hopital's rule. Now looking at how it is having a power, we need to use logs, the properties of logs. So we're going to introduce natural logs both sides, at here and this side. So it will be ln of z equal to ln of t to the power 1 over t. Now the power can drop down due to the properties of logs. So it will be ln of z equal to 1 over t ln of what? Ln of t. Now when you look at this 1 over t multiplied by ln of t is the same as ln of t over t. So this is just the same as ln of t over t. Now when t is approaching infinity, when t is approaching infinity, for this this equation, this expression is still, for the top part it is going to give us infinite, for the bottom part is still going to give us infinite, which will produce an what? an indeterminate form. So for us here again, we need to use the L'Hopital's rule. So ln of z is equals to dt ln of t over dt. So when you differentiate the top part, we are going to get 1 over t. When you differentiate the bottom part, we are just going to get what? 1. As the limit is approaching of t approaching infinite, we are going to get this expression to be what? To be 0, isn't it? But now remember, we had ln of z equal to 0 now. Now, for us, how can we find z? We just have to raise every side to the power as a power of the exponent, which is e. So what are we going to get for this? Now this shows that z is equals to anything to the power of 0, you see, is 1. But now what is z? Z is equals to 1, which is just the same as k. Now let's come up with a final answer here. Let's run through. For x we got 0, for y we got 0, then for zt we got k. So we can just combine them, since this is the same as I, j, and now we have found k. And sorry for this one, let's just make the correction now. This is t, not n. So let's compile them all. So the final answer is going to be 0i plus 0j plus k. This is our limit. This is the final answer. Thank you for watching, and we hope to see you back.